you lie and steal and cheat and beg you from my knees. Make you think she...
Alright, so guys, this video is just going to be some more practice with graphing or solving a system of linear equations graphically. So, the first thing we're going to do is, hey, just graph a line. So if we look here, we have y equals 4x plus 3, y equals negative x minus 2. So again, I'm going to graph the first equation in red. So when we're graphing equations in slope-intercept form, which is y equals, who's making the equal sign there? Mx plus b. The b is your y-intercept, but I like to say b stands for begin. So the first thing you're going to do when you graph y equals mx plus b is your b. So we're at a plus 3. We know that's our y-intercept, so we're going to go to where y is equal to a positive 3 and put our first point. Now we're going to deal with our slope. So we see here that our slope is 4x, positive 4x. Well, really that's 4 over 1. So from our first point, we're going to go up 1, 2, 3, 4 over 1. We're going to put a point. Up 1, 2, 3, 4 over, put a point. Now, when you're dealing with systems of equations, a lot of our lines aren't going to be perfectly straight because, hey, none of us are perfect at drawing straight lines unless we have a ruler. So if you don't have a ruler, the only advice I can give you is make sure you put a couple points to the right, a couple points to the left. So I went up 4 and to the right 1. So now if we go back to your y-intercept, we can go down 4 and to the left 1. All right? Down 4 to the left 1. Down 4 to the left 1. And that way, I can draw my graph through those, or I can draw my line through those points. Alright, and again, we're just going to remember where each of those points exactly were. So now, we're going to go back and we're going to graph this blue line. The blue line, again, is y equals a negative x minus 2. So when we graph this line, we're going to first go to our y-intercept, which is negative 2. So I'm going to go down to 2. And I'm going to go down 1 to the right 1, since it's a negative 1 over 1. Down 1 to the right 1. Down 1 to the right 1. Go back to your intercept and go up 1 to the left 1. Up 1 to the left 1. Up 1 to the left 1. Just so we can get our line going in both directions. And again, I'm just going to connect our dots. And go that way. And that leads us to find the intersection of our graph. So if we look here, we see that our intersection is right here, which is the point negative 1 comma negative 1. So if you go back, you know that our system, the solution to that is negative 1 comma negative 1. Make sure when you write the system of equations, you write its solution, you write it in a coordinate because it stands for an x and a y. What are those two coordinates that are going to give us the answer to our problem? So again, this is just one solution. Alright, hopefully that wasn't too much trouble. Really, when it comes to solving systems of equations, the biggest trouble kids run into is they just forget how to graph. And I'm not sure why, but I don't know. They just forget how to graph. So again, we're going to graph these lines. I'll graph the first one in red, second one in blue. So we go to our first equation, we have y equals negative 1. Now if we remember, any equation where it's y equals number and we have to graph it, that's always going to be a horizontal line, because I'm going to go to where y is negative 1 and put my first point. All right, this equation is easy because no matter what your x value is, your y value is always equal to negative 1. So if we're over here at negative 8, the y is negative 1. If we're over here at x is positive 7, y is still negative 1. And that goes back to the reasoning behind why this is going to be a why it's going to be a horizontal line at y equals negative 1. Now, right off the bat, we know that we're going to get a solution for this problem. And the reason behind that is the only type of lines that are parallel to a horizontal line are other horizontal lines. This equation is not horizontal, so we know that we can't have no solution since these lines have to touch. Also, this line has a slope and a y-intercept. This line has no slope, so therefore we know that they only can touch in one spot because these two lines aren't parallel. And we know that they aren't the same exact line, so they're not going to be exactly the same. So therefore, right off the bat, it's kind of just a tricky little way to know that you're going to get a solution. But to graph this, we'll go to our y-intercept, which is positive 4. 1, 2, 3, 4. We're going to put our point. Then here we're going to go down 5 and to the right 2. So 1, 2, 3, 4, 5. 5, 1, 2. 1, 2, 3, 4, 5. 1, 2. Alright? And I'm just going to... Did I go down 5? Did I go left? 1, 2, 3, 4. Oh, sorry, that first point was wrong. I looked at it and knew that it was wrong. 1, 2, 3, 4, 5. 1, 2. Sorry about that. 1, 2, 3, 4, 5. 1, 2. Now, I know I said in the last one to make sure that you do a couple points to see where your intersection is going to be. But once we know that intersection is going to be that second point we plotted, you really don't have to plot many more because your intersection is already going to be found. So again, we're going to go back. We want to find our intersection, which is up there. So it's going to be positive 2x, and our y is going to be negative 1. Now, again, you would have known right off the bat that your solution to this, which again is one solution, was going to have the y value of a negative 1, because the only y value that the red line goes through is negative 1. So really all you had to do was find the x, but again, in order to find that, you would find it graphically. Now, if we had this type of equation and we were going to solve this later on when we learn another method, graphing would not be our probably preferred method to solve this system. But we're not going to learn that method until later sections. So just keep in mind that with all algebra, or basically all of algebra, there's multiple ways to solve each type of problem. And if you're not told to solve it a specific way, knowing little hints and tricks will help you out. But I'll explain that more further down the road. So if we look here, we have two more equations. We have y equals negative 2x plus 2 as the first one, and y equals negative 2x minus 1. Now I'm going to graph this first line in red. So the y-intercept is going to be positive 2. I'll put that there. Our next point, since it's a negative, really negative 2 over 1, we're going to go down 2 to the right 1, down 2 to the right 1. And then back to y-intercept, up 2 to the left 1, up 2 to the left 1. The reason why I can do down 2 or to the right 1 or up 2 into the left 1 is because those are just opposite directions. And we know that it's okay because our graph's going to be decreasing, negative slope, but that's that one. Now we're going to go to our blue one. We're going to go to negative 1, and we're going to graph again the slope. So we're going to go down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. Go back here, up 2 to the left 1, up 2 to the left 1, up 2 to the left 1, up 2 to the left 1. And again, we're going to connect our line. And I hope you guys saw a pattern here. When I was doing the slope, the blue line and the red line are never going to touch. Okay? And that's because these two lines are parallel. So we know that if two lines are parallel, our answer is going to just be no solution. Now, like I said, if you remember the relationship between two lines that are parallel, and talking about their equations or their characteristics, you would know that if two lines have the same slope and different y-intercepts, they're going to be parallel. Right off the bat, you see that it's y equals negative 2x plus 2. This is your slope. Okay? And if we notice, it's exactly equal to the slope of that line. So right off the bat, we know that these two lines could be parallel. The next thing you have to look at is their y-intercepts. Here's your y-intercept. Alright? Positive 2 and a negative 1. They're different y-intercepts. So these two lines have the same slope, different y-intercept, therefore we know they're parallel, therefore we know there's no solution. But in order to solve that graphically, we must graph them. But again, this is nice because if you can see this off the bat, you'll know that the final answer you get when you graph it could be right or wrong. Because if we got a solution for this, if these two lines intersected, we know we graphed them wrong because their equations tell us they're parallel. Just like this problem, since you know that y equals negative 1, the only solution these two could have the y value has to be a -1 because that's all y can equal for this equation. So say you did your answer and you had 2 comma 2, you knew you're wrong because, well, the y value has to be a -1, so therefore it can't be a 2. So even though sometimes it's nice to know what your answer is going to be before you do the problem, you still need to do the problem to show that, one, you know what you're doing, and two, to kind of back up your reasoning, kind of prove your reasoning and why you're right. But that's just a little hint and something you can do if you keep your eye out. So what I'm going to do here, I think this is the last one. Yeah, we'll do the last one here. I want to do this one just because the slopes are funky, so it'll be tricky to graph. But again, the process is exactly the same. Graph both your lines, find out where they meet or if they meet, and that's your solution. So we got this first one, we go to -2. All right, I'll go here. Y is -2. And then our slope's in -1/2, so I can go down 1 to the right 2, down 1 to the right 2. Go back to your y-intercept. Instead of going down 1 to the right, we can go up 1 and, oops, up 1 to the left 2, up 1 to the left 2. And then we'll draw our line. And I did not draw that line through the dots at all, but that's okay. We still understand the purpose. All right, so now we're going to graph the blue one. We have y equals -3/x plus 2. So we're going to go up to a +2. Our slope is -3/2, so we're going to go down 3. 1, 2, 3, over 2. 1, 2, 3, over 2. Back to it. Up 3, over 2, up 3, over 2. Now what I'm going to do is I'm going to graph it. All right, and we can see that our solution is this guy right here, which is going to come out to 1, 2, 3, 4, 1, 2, 3, 4. So it's going to be 4, comma, -4. Or I'll show you actually. So it's 4, comma, -4 is our solution. Again, draw your solution as a coordinate, and that is one solution. All right. And that's that. That's how you solve a system of equations graphically. Remember that when you're solving them graphically, you're going to have 3 different types of answers. One solution where they touch in one point. No solution, the graph's gone, but the lines are parallel, they never touch. Or infinite solutions where it's the same exact line for both of your equations. Or all 3 or all 4 or all 30 of your equations. Because a system of equations is not limited to 2, but you can actually have unlimited. We're going to deal with more than 2, probably at the end of this section, or the end of this concept. So stay tuned, watch the videos, check out some documents, have fun.
Keep your love.